Chapter 2, Section 3. In this section we're going to talk about a couple quick methods for graphing linear equations. The first one is slope-intercept form. Standard form for the equation of a slanted line is ax plus by equals c. To use the quick method, slope-intercept form, solve the linear equation for y, putting the equation in slope-intercept form, y equals mx plus b. B is the y-intercept and m is the slope. We can use these two values, m and b, to graph the line. And you want to remember that slope is rise over run. The second quick method is using x and y intercepts. The x-intercept is the place where the line crosses the x-axis. To find the x-intercept, let y equal 0 and solve for x. The y-intercept is the place where the line crosses the y-axis, and to find the y-intercept, let x equal 0 and solve for y. Using these two ordered pairs, c0, the x-intercept, and 0b, the y-intercept, we can graph the line. In this first example, we're going to graph y equals 1/2 x plus 1. Because that equation is in the form y equals mx plus b, we can use that quick method to graph the line. All we have to do is pick out the y-intercept, and the y-intercept in this equation is 1, and pick out the slope, rise over run. That slope is 1/2. The slope is multiplied to x. Okay, to graph, I'm going to graph the y-intercept on the y-axis. The y-intercept is positive 1. And then from there, I'm going to use the slope to find more points. I have a rise of 1 and a run of 2 units. They're both positive, so I'm going to go up 1 in the positive direction and to the right 2 in the positive direction to find points. And I can continue that pattern and find as many points on this line as I like, and then draw the line through those points. Make sure to put arrows at both ends to show that the line goes on and on forever in both directions. Fill up your graph with your line. Don't stop at the points that you've graphed, because then you would just be graphing a line segment. Okay, the second line that we're going to graph is 3x minus 2y equals 6. This equation is in standard form, and because the coefficients 3 and -2 both divide evenly into 6, using x and y intercepts is a good choice, good method for graphing this line. So I'm going to first find the x-intercept by letting y equal 0. So I've got 3x minus 2 times 0 equals 6. So 0 times -2 is 0, so I'm left with 3x on the left. 3x equals 6, and dividing both sides by 3, I find that I have an x-intercept of 2. So I can graph the ordered pair 2, 0 on the coordinate plane. Okay, then finding the y-intercept by letting x equal 0. I get 3 times 0 is 0, so I'm left with -2y on the left and 6 on the right. And dividing both sides by -2, I find that the y-intercept is -3. So I have the point 0, -3 on the coordinate plane. So graphing 0, -3 on the y-axis. Now I can draw the line that I'm graphing through those 2 points. Again, I filled up the graph with my line, and I put arrows at both ends to show it goes on and on forever in both directions. Remember, it only takes 2 points to determine a line, so using the x and y intercept is a good method. Okay, here we're graphing 2 special lines. Standard form for the equation of a horizontal line is y equals b. If we graph the equation y equals -2, we're graphing a horizontal line that crosses the y-axis at -2, and it looks like this. For all x, y is always -2. Any point on this line, you can see, is going to have a y-coordinate of -2. The ordered pair that names this point is 1, 2, 3, 4, 5, 6, -6, -2. This point is 0, -2. And the third point I graphed is 1, 2, 3, 4, 5, -2. Again, every point on that horizontal line is going to have a y-coordinate of -2. Its equation is y equals -2. Okay, standard form for the equation of a vertical line is x equals c. We're going to graph x equals 5. So we're graphing a vertical line that crosses the y-axis at 5. 1, 2, 3, 4, right here, 5. So I'll draw this vertical line through that point on the x-axis. And then again, I'll just locate a couple other points on the line. And you can see that every point on this line is going to have an x-coordinate of 5. This one goes up 1, 2, 3, 4, 5. So this point is at 5, 5. This point was 5, 0 on the x-axis. And this point is 5, -2. Every point on a vertical line has an x-coordinate the same, and in this case 5, because the equation is x equals 5. For all y, x is always 5. Include in your notes of this video guided practice problems 6 through 14 found on pages 90 and 92 of your textbook.